reviewing the long division, 3.3. Long division. I know you know this. You can say again, yeah, well, we need it for 3.5. That's why. We do not cover 3.4. So it's 3.3, 3.5, and 3.6. And that will be the end for chapter 2. For test 2, I meant. Okay, so long division. In this section, we have two options, a long division and synthetic division. But I think that if we know the long division, which can be applicable in all situations, except when the denominator is one term, and we don't use long division when it's one term, I think this is good enough. Synthetic division I can show you, of course, with pleasure, but it has limited applicability. It's only applicable when the denominator is exactly two terms and a specific form of two terms, etc., etc. Yeah, it's very similar. But it can only be applied when the denominator is x minus 1 or x plus 5 or x plus 3, not when it's x squared minus 2x plus 1. Okay, so let's start. So these problems are on page, you can choose if you'd like. They are on page 392. Let's start with 21 on 392, and then you can choose the next one. 4x cubed minus 3x squared plus 3x minus 1. Everything divided by x minus 1. What is the degree of the top? 3. What is the degree of the denominator? Perfect. So is there a missing term from the top? And you can say, how do I know? Very easy to know. Degree 3 is there, degree 2 is there, degree 1 is there, degree 0 is there. No missing term. For example, if I have 6x to the 4th minus 3x plus 2, a lot of terms are missing. What is the degree of this? Is the degree 3 there? No, so that term is missing. Is the degree 2 there? No, that term is missing as well. Degree 1, degree 0. So 2 missing terms, but not here. So we are ready to start the algorithm. So 4x to the 3rd minus 3x squared plus 3x minus 1 and x minus 1. Now, if a term is missing, then I will have to leave a blank space. So if this term were missing, I would have had 4x cubed blank plus 3x minus 1. Now, our first question here is x times what is 4x cubed? 4x squared, do we all agree with that? We go back now and distribute to both terms, change the sign to the opposite sign, and write below like terms. Ready? 4x squared times x is 4x cubed. I subtract. 4x squared times negative 1 is negative 4x squared. I subtract. Perform the operations I see and bring down the next in line. X times what is x squared? Exactly. At the top, we do not lie. So it's positive x. We always have to write a symbol. X times x is x squared, but I have to change because I subtract. X times negative 1 is negative x, positive x. 4x and bring down the next in line. Final question, x times what is 4x? Symbol or operation symbol? Very good, awesome. 4 times x is 4x, I subtract. 4 times negative 1 is negative 4, I subtract. I box in 3. What does 3 represent? It's called the remainder, very good. What is this called? Quotient. So the answer will be the quotient 4x squared plus x plus 4 plus, please do not forget this symbol, either plus or minus. In this case, it's positive over x minus 1. And let's suppose we say, show me that this is true. How will I show you? I need to convince you that this is correct. True, but I want to check my work. How will I check my work? Any suggestions? Multiply x minus 1 by and add. And what should I obtain? Yes, if I don't obtain this, when I multiply this by this and add 3, then the answer is wrong. So I'm going to check myself. I'm going to multiply this by x minus 1. So 4x squared plus x plus 4 times x minus 1 and plus 3. So I'll distribute first, of course. I have to. X times 4x squared, 4x cubed. X times x, x squared. X times 4, 4x. Negative 1 times 4x squared. Negative x, negative 4, and plus 3. Now let's see what happens. This is alone. These are together. These are together. And this is minus 1. And now I look. 4x cubed? Yes. Negative 3x squared? Yes. Positive 3x? Yes. Minus 1? Yes. So therefore, this is correct, and the remainder is correct, and this is the divisor. I know for sure that this is the correct answer. This times this plus this was giving us that. How come? Where does this come from? Very simple, from here. 3 integers and 1 over 3. 3 times 3 is 9, plus 1 is 10. Is this okay? Good. Do we want to look at other examples of long division?
Yes.
Very good. Would you like to choose? Would you like to choose one with a gap?
Yes.
Okay, let's choose one with a gap. 27. By gap, I mean not having all terms at the top. So we have to leave some room for that. Okay.
Gap is what called it.
Missing term, actually.
The book
Yeah,
is that the same as a whole that the book calls it?
No, very good. You're way ahead of me, of course. It's in 3.5. That's a section that I don't think I can start today. It's about rational functions. And when you have a factor at the top and a factor in the denominator that go away, that is not a vertical asymptote, but a hole in the graph. Okay?
Different from the gap.
Different from that, yes. Yes, sorry about that. So 27, x to the 5th plus x cubed minus 2 over x minus 1.
Will they all have over x minus 1?
No, let me choose something else. Let me choose something else. I don't want to confuse you. $28. X to the 7th plus x to the 5th minus 10x cubed plus 12 over x plus 2. Is this okay? Good. Good. Top and bottom in descending order, yes or no? Good. Indeed. Degree 7, degree 5, degree 3 in descending order, and degree 1 and 0. Yes. What is the degree of the numerator? Good. Okay, so I start with x to the 7th. Is x to the 6th there? Space. X to the 5th. Is x to the 4th there? Space. Is x to the 3rd there? Is x squared there? I have to start from scratch. I don't have enough room. So x to the 7th, positive x to the 5th, so 4, negative 10x to the 3rd, space, plus 12. Okay, very good. So x times what is x to the 7th?
X to the 6.
Yes. At the top, we do not lie. When we write underneath, we have to change the sign because we subtract. But in the quotient, we never lie. You know what I mean. We never lie anyway, but I just wanted to trigger your memory. Okay, ready? Now I'm going to put my hand there. You know that. So x to the 6th. X to the 6th times x is x to the 7th, but I subtract. Careful now. X to the 6th times 2 is 2x to the 6th, but I have to subtract, and I cannot write it under x to the 5th. And if you're wondering, no, you're not going to have a problem like this on the test. This is going to take a while. Okay, next question now. X times what is negative 2x to the 6th? At the top, we do not lie. Yes. Remember, if you had x to the 6th, the next one cannot be x to the 6th or more. It has to be lower. Good. Negative 2x to the 5th times x is negative 2x to the 6th, but I have to change the sign because I subtract. Negative 2x to the 5th times 2 is negative 4x to the 5th. Oh. Combine like terms. The next one in line will be this. So we'll see if I can use that or whatever happens. X times what is 5x to the 5th? Five x to the 4th times x is 5x to the 5th. 5x to the 4th times 2 is positive 10x to the 4th. I don't have a 10x to the 4th. So plus 10x to the 4th. Plus, minus. I forgot to change the sign. Sorry. I'm talking too much. So 10x to the 4th minus 10x to the 4th. Bring down. And now I can bring down negative 10x to the 3rd. X times what is negative 10? Yes, of course. Thank you very much. I was just looking at that. I would have said, oh, no, something's wrong. Okay, x times what is negative 10x to the 4th? Yes. 6, 5, 4, 3. Good. Negative 10x to the 3rd times x is negative 10x to the 4th, positive 10x to the 4th. Negative 10x cubed times 2 is negative 20x cubed, positive 20x cubed. Okay, 10x cubed. X times what is 10x cubed? 10x squared. Very good. 10x squared times x is 10x cubed. Subtract. 10x squared times 2 is 20x squared, but I subtract. There is nothing I can combine with. I'm running out of paper. Okay, there's nothing I can bring down, so only 2 more terms, but still I've run out of options here. So x times negative 2 times what is negative 20x squared. So it's negative 10x. Negative 10x. Now we distribute. Negative 20x squared, so positive 20x squared, and negative 20x, so positive 20x. So I have 20x plus 12.
Isn't the negative 10x at the top supposed to be 20x?
Yes, of course. Thank you. Thank you. So it's 40x plus 12. I'm checking now. Negative 20, yes. Yes, and then negative 40, positive 40, positive 40, and 12. Yes. So then finally plus 40. Positive 40x minus 40x, positive 80 minus 80, and this is negative 68. So what is the answer? All this minus 68 over x plus 2. So I'm going to write the answer here. X to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40 and minus 68 over x plus 2. No, don't expect something like this. There is no need for this. Well, we chose an example to see it. Any questions? Any questions? We do not cover 3.4, as I mentioned. I only have, because I promised to give you 2 minutes back. I stole 2 minutes away from you last Monday. So basically I have 3 minutes left. I don't want to start 3.4, as I said, we don't cover. I don't want to start 3.5 in 3 minutes. 3.6 is a very easy situation, really easy. But 3.5 requires a lot of work.